In this module, I want to share with you some thoughts about strategic planning in waste management, and specifically with regard to integrating biowaste management into the municipal system. So why biowaste management? Let me briefly repeat what we have learned so far on biowaste management. Biowaste is the largest fraction, with over half of all municipal waste consisting of biowaste. When collected and disposed of in neighborhoods, biowaste may impact negatively on the environment. While degrading, it may generate methane, a potent greenhouse gas. Biowaste is also an environmental threat. Leachate from biowaste pollutes groundwater and surface water. And biowaste may attract or even promote disease-carrying vectors like flies or rodents. It is also an underutilized resource. Whereas recyclables like glass, metal, paper, and even some fractions of plastic already have a quite well-established recycling market, biowaste is still struggling. However, treatment technologies exist. You have heard about them in the previous modules. And municipalities are slowly but surely becoming more and more aware of the potential to manage biowaste as a separate fraction and make use of this resource. But how to go about this in a well-planned and systematic way? What to choose? Often decisions are taken like, oh, what should we do? Or what do the donors suggest? Okay, we'll just do composting at the landfill and that might work. Actually, and unfortunately, it'll probably not work. In this module, I shall try to guide you through some planning steps to come up with some informed decision on what to do with biowaste. The planning steps we shall go through are those typical of any project planning cycle, as you see in this graph, something you might have come across already. The first step is identifying problems and needs based on an assessment of the existing situation. Then developing goals, generating weighting objectives, and elaborating on potential actions to meet these objectives. The next step is then preparing scenarios that address the alternative futures in biowaste management, comparing each scenario's impact, cost, and constraints, and examining stakeholders' willingness to pay for or cooperate. Then developing and reaching a consensus on both selection criteria and the choice among scenarios that best address the objectives. And then finally, following through with implementation, operation, monitoring, evaluation, and adaptation, summarized in these boxes. The first step involves the preparation and an initiation of the planning process, as well as framing the problem. You want to make sure to have support of key stakeholders, typically the local authorities, but also ensuring enough human and financial resources to conduct the process. This will include a professional facilitator as well as technical experts for the appraisal of options later. Then, a next step is to identify the relevant stakeholders for this participatory process. A subsequent task is to then frame the decision problem. This means defining the area of concern, assessing waste types and amounts, as well as the origins of the waste and the accessibility to the waste. What you see in this table is an example of different types of biowaste. In the columns, you can then see the descriptor of origin of generation, the amounts, the variations over the year, but what is also essential information is to know how the waste type is currently being managed, if at all. If a recovery and recycling pathway is already established, it makes little sense to disrupt this. An example is the case of certain types of vegetable waste from the markets that are already sold or left to farmers for feeding livestock. The next step in the cycle is defining the goals and objectives with the respective sub-objectives. An example is shown here in this objective tree. This objective tree can be validated or even adapted in a participatory process. During this process, different objectives can also be weighted depending on the perceived importance. This example shows some predefined sub-objectives grouped under different headers which were developed by expert consultation. There is the issue of technical reliability, social acceptance, the aspects of environmental pollution, of high hygiene and health protection, and finally, the aspect of economic sustainability. Then, the next step is to select the various alternatives and assess their performance with regard to the objectives we want to achieve. Here is a list of different biowaste treatment options as we have heard about them in the previous modules. We can now assess their suitability regarding all those performance criteria we had in the objective hierarchy. Here are some examples. For instance, the waste type, which is in the technical objective, or the availability of skilled people, also in the technical objective, or the market of the products, which is one under the economic objective. So let me say a few things more about this economic objective. Given our experience, we have noticed that many municipalities feel that making, for instance, compost will solve all their problems, and they might even make a lot of money. Typically, this is not so without a very well planned distribution and marketing approach. Maybe at the end, the compost is then used as cover material at the disposal site. And this would be fine and makes a lot of sense. The main point is that it is thought through at the onset of the planning. This aspect of economic sustainability not only necessitates a good understanding of the costs, but also of the expected revenues. So the potential value of the product being made from biowaste, be it gas, protein, or soil amendment. In biowaste management, it is in fact this aspect which is currently most difficult to assess, as the databases for making such estimations is quite weak. We at Sandec are putting a lot of effort in trying to quantify treatment costs for the different options, or we could also say production costs for that specific product that we make from biowaste. If you have such information from your specific context, please post it onto the forum, and we will compile it and use it for our reports and even future lessons. When assessing the alternatives, we come up with scores on how they perform towards certain objectives. It is important to discuss this performance of alternatives, to look at scores and discuss trade-offs. Then we might find a consensus of the best practicable alternative. This then needs a detailed feasibility assessment. Detailed because we start defining scale, we start defining location, and even the logistics around it. All our experience from biowaste management shows that it is best to have a pure biowaste stream. This ensures high quality product and, of course, minimizes cost of sorting. Sometimes it is best to start with easy waste, waste which is not contaminated by non-degradable fractions, like waste from vegetable markets, or pre-consumer waste, or waste from food processing industries or restaurants. If we want to target household waste, it is crucial that we first mobilize and incentivize waste segregation at the household level. So in summary, strategic planning of biowaste management includes the process of assessing alternatives in biowaste management, deciding on the objectives that we want to achieve, assessing the different waste types and the source, and validating the performance of the alternatives versus the objectives. And one key realization is that segregation is really a key step for all future biowaste management. Thank you for listening.